discussing variations of projectile motion, including projection from an elevated point and also projectile motion on an inclined plane in the last lecture. So let's take it forward from that point onwards. We'll discuss few more examples of projectile motion, especially the inclined plane version. Then we'll also discuss any doubts and questions that you might have from either HC Verma or from the worksheet which I have sent earlier. Okay, so let's start today's session. Okay, Rohan, we will discuss that question. Okay. Whatever questions or doubts you have from either the worksheet of projectile motion or from HC Verma, if you have any questions, please send it to me on the text message. Is a question number and the source of the question. We will discuss it in a bit of time. I just want to discuss a couple of examples of projection on an inclined plane, then we'll come back to that. So let us look at an example of projection from an inclined plane. So this angle is 37 degrees this time. And let us say we have projected something at an initial speed u like this. Which is making an angle of 45 degrees, okay, with respect to the inclined plane like this. Okay. So similar to a question we had done last time, but we had projected it from below. Okay. So again, this time let's take u as 70 meters per second. Let's take g as 10 meters per second square. And let's take 1 by root 2 as approximately, or let's take root 2 as 1.4. Okay. So we have to find again those standard kind of things. Find the maximum distance, the range, the impact, speed, the time of flight, okay. So start this question. Started by first of all, choice of reference frame, take x and y axis properly and all that. Okay, so I'm setting up the equations. Okay, just continue working on it if you're already in the process of solving. So what we'll do is we'll take the direction down the inclined plane as our x-axis, and we'll take the direction perpendicular to the inclined plane like this as our y-axis. So our initial velocity vector is like this. And our acceleration due to gravity vector will be like this. Very good, Kirti. I'll just verify the answer. So our initial velocity, we will have to resolve it like this. U cos beta I cap plus U sin beta j cap. So when we do that, this here is our acceleration. So once you get these equations, now it's quite easy to show the equation of trajectory. So at some time t, the velocity vector, coordinates, etc. So these are our important equations. Now we can see that from here at t equal to capital T, y coordinate is 0. So that's our time of flight. X coordinate is equal to range. So
So that's the total time of flight.
Yeah, this is the time of flight. When it hits the inclined plane, the y coordinate is 0, right?
Yes, sir.
The x coordinate will become 50t plus 3t square. Kirti, have you got the same time of flight?
Yes, I think I did some calculation. The time of flight is
Just check check your answer. Okay. So that is about time of flight and range. Okay. Now you can see that the maximum distance from the inclined plane is y coordinates maximum. A y coordinate is 50 minus 4t square, 50t minus 4t square. That is like this. Okay. So you can see that y is equal to 0 at t equal to 0 and t equal to capital T, which is 12.5 seconds. And y is equal to maximum at t equal to 6.25 seconds. Okay.
Sir,
So the maximum distance, yes.
sir, time of flight is should be 3.5 seconds, right?
How is coming 3.5 seconds?
There is the same equation. U sin beta t.
You have got the same value. Y. This equation you have to solve. No?
Yes, sir.
Just factorize it and solve. Okay. So this is basically 50t minus 4t square is 0. Take 4t common. See, you're getting initial time and okay, it's all right. The calculation is clear, beta.
But sir, but U sin
2u sine beta divided by g cos alpha. No? So use that also. 2 into 50 into sine beta is how much? Sorry, 2 into 70 into sine beta is 1 by root 2. So 1 upon 1.4 divided by g, which is 10 into cos alpha, which is 4 by 5. You get the same result if you do this. 2 into 50 divided by 8. Okay, so I hope the calculation for these three things is clear so far. Now for the impact speed, you just find the individual components of velocity at the time of impact,
Sir,
and then find the magnitude of that velocity.
sir,
Yes.
sir, I approximated the answer a bit for height. Is it like just 3-4 meters behind?
So but I could not hear you clearly. You speak again.
Sir, I approximated the height.
Approximated the height, but how you approximated?
So like I took 1.5 instead of for root 2.
What did you take as 1.5?
So root 2.
But root 2 is given to you to take as 1.4, na beta? The question itself, no, it was given that you have to take root 2 as 1.4. No? So if some approximation is given in the question, you should always use that, because the answer will come according to that approximation. No? In any case, you know the value of root 2 is 1.414. So the correct approximation is 1.4. Okay. Okay, now for impact velocity, you have to just find this final thing now, that at t equal to capital T, the value of velocity is the final impact speed. So your x component will become 50 plus 6 into 6.25. Okay, and your Vy will become 50 minus 8 into 6.25. Okay. And your impact speed will become square root of this Vx square plus Vy square. Okay. So to save some time, I'm not doing the calculation, but just understand this is how you'll find it. Okay. So now I will move on to the questions and doubts that you have sent me. So far I have received from Rohan question number 9. Is it? Or is it 9? Okay, 9 some and
Sir?
14 and 20 from Yash. Yes.
Sir, can we send the question number or the picture?
You can send just the question number. Now, if it is from the worksheet which I have sent or from HC Verma. If it is from some other source, then I will not have the question. So you have to send the picture. Okay? So let's pick up doubts from the worksheet of projectile motion first. So I'm starting with question number 9, but so far I have received requests for 9, 14 and 26. So these are the questions we are going to cover next. And also 25. Okay. Right. So let's start with this. If you have questions from HC Verma also, you can just send me the question number. That is sufficient. Okay, so let's go through question number 9 first. Okay. Yeah, a bit of calculation in this question, especially units and all. So the projection speed is given to you, the angle of projection is given to you. Okay, fielder is 7 feet above the ground and okay, against the bleacher wall, which is 386 feet from the home plate, and the ball was 3 feet above the ground when it was projected. Okay. So this 26 degrees, we can use a table to find sine and cos. Okay. Sine 26 and cos 26 if we look up in the calculator. Okay. But it's reasonably close to 30 actually. So we'll see that sine 26 is going to be approximately equal to sine 30. So you can even use an approximate value of half. And similarly, cos 26 is reasonably close to cos 30, which is root 3 by 2. So you can use these values only. Okay. And also G's value we'll take as in feet per second square. So it's 32 feet per second square. And use the conversion factor that 1 meter is, I think, 3.05 feet or something like that. Okay. So anyhow, let's pick up the data of this question and solve this numerically. So first of all, let me explain the situation. Okay. On the baseball field, there is what is called the bleachers wall at the end. Okay. And the hit is made from somewhere here, let's say. The speed u at an angle theta like this, where this is 3 feet above the ground. Okay. This is going and hitting the wall somewhere here, let's say. And during that time, the fielder has made a jump such that his hand is at a height of 7 feet above the ground. Okay. And this distance this is given to us as what is it now? 386 feet. U is given to us as 132 feet per second. And theta is 26 degrees. Okay. So what we'll first of all do here is we'll take this as our x-axis and this as our y-axis. And with respect to this origin, then we can take this point as some unknown height h. Sorry, the horizontal coordinate x is equal to d at this point, and the y coordinate is some h which we need to calculate, where h will be this height, not the height from the ground but the height from the x-axis. That will be okay. So to calculate this, the easiest thing is to write the equation of trajectory. The equation of trajectory we write in this form, that y is x tan theta into 1 minus x by r, where r is equal to u square sine 2 theta divided by g. So here that will be 132 feet per second square into, we'll take this approximately as, okay, this much. So let's do this calculation for r. So r will come out to be approximately 471 feet. Okay. So my equation of trajectory is y is equal to okay. Now to find h, we'll just substitute this value here. So h, which is the unknown, is the x coordinate, which is 386. So this will be approximately so from that you can find out how much above his hand this is going. Okay, we want to calculate this distance. So let's that say that distance is some capital D or whatever. So that will become h minus 4 feet. We could also do a more accurate calculation. Okay, so a more accurate calculation will involve taking theta as 26 degrees. Okay. So that will be like this. Now, tan 26 similarly, it's about 0.49. So it's almost half. So if I use a more accurate calculation, so I'll get this h as let's check if this is closer to the answer. Yeah, actually, the approximation I've done earlier is not a very good one. So don't do this approximation. Use this above one that I have done. So we're getting h as this. Okay. So we'll get that distance d as h minus 4. 15.34. Okay. Yeah, so the approximation I did earlier was not a very good one, because actually what happens is that the tan function actually it increases very rapidly. So tan 26 approximated as tan 30 was not a very good approximation. It's better to use this. This sine 52 degrees is, let's give you the value. It's very close to sine 57 actually, 53 actually. So it is 0.79. So you can might as well use 0.8. That will be okay. And similarly here, tan 26 when you do the calculation, we 0.49, which I have approximated as 0.5. Okay. So if you use these values, even the calculation is easier, and secondly, like it's quite accurate. Okay. Anyhow, so hope the question is clear. Especially to you, Rohan. Hope the question is clear.
Yes, sir.
Okay, very good. Now,
Thank
next we are moving on to no problem. Okay. Next, which question we are doing? We are moving on to question number 14. Okay. So finish writing this down and then go through question number 14. We'll discuss.
There is a marginal difference of around 1 or 2 units in difference between the answer and the answer given is fine.
Yeah, I mean, it's about actually accuracy. What is the answer given in this question?
No, for not for this question. I'm talking about question number 14.
Okay. Generally, now you should not have a huge difference. Like the thing is, like your difference should not be more than about 5%. You know, if you're doing approximations, the difference should not be of more than about 5%. Okay, so for example, if the answer is 100 and you're getting the answer as 99, it's okay because it's a 1% difference. But if the answer is only 3 and you're getting the answer as 2, okay, then that's a huge difference. That's 33% difference. Okay, so it should be reasonably close.
Yes, sir. So for example, one answer is given as 51. I'm getting 49. That's fine. Right?
That's fine, and that might be because of certain values that you've taken. Might be because of a difference in the value of G.
Yes,
In the
sir.
question, they might have taken G as 9.8, and you've taken as the more standard value of
Yes,
10
sir.
meters per second square. Usually, those type of differences come because of that. So, otherwise, you are clear with the concept of the question, or you want
Yes,
to
sir.
discuss the question?
So no, this is not my doubt actually. I just asked.
Okay, right. Okay. So anyhow, we'll discuss this question, 14th one, and we'll move on next. Okay, so let's go through the question. Okay, so stone is being projected at a cliff of height h, with initial speed this much, 60-degree angle above the horizontal, as shown in the figure. Okay, strikes at the point A 5.5 seconds after launching. To find the height of the cliff, the speed of the stone before impact, and maximum height reached, and all these things. Okay. So what is happening here is we have to deal with the time-based equation, because what is given to us is the time. The time at this position is 5.5 seconds. Okay. Assume the launch time is t equal to 0. So you can see that the y coordinate in general is u sine theta t minus half gt square. So here h is the unknown quantity. Okay, but this is 42 sine 60 into 5.5 minus, so this will give us the h in meters. So minus sign in between. So this will give us h. Okay. And speed of the stone at the time of impact, we can just calculate like this, that over here, if it has a vertical speed vy and a horizontal speed vx, I mean horizontal component vx. So vx is u cos theta. So that is 42 into cos 60 or 21. Now Vy, the easiest way to calculate Vy is use this, that Vy square is equal to u square sine square theta minus 2gy. Okay. And put that value of y as h, which you got above. Okay. Or you already know the time, so you can use that also. You can also use that Vy is u sine theta minus gt. You already know the value of time, so even this is reasonably easy. Minus 10 into 5.5. So from this you will get the value of Vy. And once you got Vy, you can find the speed at it has before the impact, just before impact. Okay. So Yash, can you complete the calculation part from here? Is this concept clear for A and B part?
Yes, sir.
Okay. And maximum height, directly use the formula. Okay. So u square sine square theta by 2g. So for this, you didn't even need the other data which was given. You just need this u, this theta, and the value of g. Okay, now you might not get 100% accuracy by taking g as 10, because the answer key might be given according to g as 9.8. Okay, so just take that into account when you're checking your answer. Okay, so is this question clear, Yash? Can I remove the solution now?
Yes, sir.
Okay. So next we are moving on to question 25. Okay, so let's just go through the question first. Okay. Particle is projected so as to clear a wall of height h at a horizontal distance a and to have a range b from the point of projection. Find the velocity of projection. This is a very nice question. I would like you people to consider the diagram and then use equation of trajectory. Okay. So I'm just making a rough sketch of the diagram. Okay. So the information that is given to us about this is that this range, this is given to us as B. And let's say this point over here, it has a height h, it just clears a wall. So let's say this is a wall which is of height h at a distance e. So this point, if it has coordinates x, y, x is equal to a, y is equal to h. So from that we have to find the velocity of projection. And you can find number of things actually. You can also find the angle of projection, velocity and all that. Okay. So use equation of trajectory. Okay. Just try this question. I'll give you a hint also how to solve the final thing first. But try to fit the data in the equation of trajectory. So basically you have two unknowns. So you need to generate two equations. So the first equation you can use is use equation of trajectory. Okay. At the point P, where P is this point. And second is use formula for range. And then between the two equations, you have to solve for U.
So we have to use that long expression, right? X tan theta minus half gx square.
You can use that, but because the range is directly given in terms of B, so you can use that equation, the type I've shown you by in terms of range instead of in terms of U square cos square theta. You understanding now?
Yes, sir.
The second form of equation of trajectory, the one we always use in problem solving actually. X tan theta whole thing into 1 minus x by r. Use that. Okay, so directly substitute the value of r as B, but theta is unknown in that. Tan theta is unknown. but that equation should be satisfied by this point P. So that will give you one relation, and from that you will actually get the value of tan theta. Okay. And then you have the formula for range. So from that you can find. Okay, so let's work this out. So equation of trajectory is that y is equal to x tan theta into 1 minus x by r. So in this you put the value of r as b, which is given, and put this point's coordinates for x and y. So you have the relation that h is equal to a tan theta into 1 minus a by b. Okay, this is the first equation you have. And the other equation you have is for range. So b is equal to u square sine 2 theta divided by g. Now in this, so we have to find the velocity of projections. You have to find u. So what you can do is from here you can substitute tan theta as how much will it become bh upon a into b minus a. Nice. Now, do you know this identity that sine 2 theta can be expressed in terms of tan theta? You know this?
Yes, sir. 2 tan theta upon 1 plus tan square.
So just ये use कर लो यहाँ पे ना. So put tan theta as this and then substitute sine 2 theta here. You can see you are getting the value of u square.
Okay, sir.
So it's a manipulation based question. That's why you might have found it little difficult. If the numerical values of A, B, and H were given to you, you would have found it easier because you would have got a numerical value of tan theta from that. So, anyhow, so hope the concept is clear. Okay, so finish this up and we will next look at question 26. So just go through this question. Yes, tell me.
So after finding sin 2 theta, we'll substitute in that range formula, then we then.
हाँ, मतलब sin 2 theta को tan theta के terms में substitute कर दो और यहाँ पे tan theta को इतना substitute कर दो, you know, bh upon a into b minus a like that. Okay, so it will become a kind of complicated term in terms of a, b, and h, but it's a known quantity, you know. So now in this equation, u square is the only unknown quantity.
Yes, sir.
Okay, so I'm clearing this now. This concept is clear now.
Yes, sir.
Okay. Now let's move on to the last 26th question of this part. Okay. Time of flight for two paths corresponding to two possible directions of projection to get a given range are in the ratio 2:1. Okay. Yeah. So for this, you know the concept that if you have one time you project something at, let's say, an angle alpha and you achieve a certain range. And you achieve a certain height and time and all that. Okay. Another time you project that same object at the same speed, but at an angle beta. Okay. It's always possible that when you project it, you will come back to the same range because so if this range is equal to this range, it means that sine 2 alpha is equal to sine 2 beta, which means that 2 alpha should be 180 minus 2 beta, which means that beta should be, or alpha plus beta should be 90 degrees. So if beta is equal to 90 minus alpha, then this range will be the same as this range. Okay, but the time will be different. Okay, because it's going to a larger height, so the time will be 2u sine beta divided by g, which according to this will become 2u cos alpha divided by g. So the ratio of these two times, okay, because time of flights का ratio दिया हुआ, so t is to t prime is given as 2:1. So t by t prime from this you can see is basically sine alpha by sine beta is equal to 2. So here it will become sine alpha by cos alpha is equal to 2. Okay. So alpha is tan inverse 2 in this case. Okay. So now you know that this is the value of alpha. Okay, now I'll come to the next part of the question. Okay, but write down this part first. Okay, so if you're getting the same range for two angles, alpha and beta, but the time of flight and the ratio is in the ratio 2:1, then alpha must be tan inverse 2 and beta therefore must be 90 minus tan inverse 2. Okay, this. Now from this we have to find this information that whatever range we are getting in this case, when we are taking the angle of projection equal to either of these two with respect to the maximum possible range, we have to find that ratio. Okay, So this particular range is u square sine 2 alpha divided by g. So it is u square. Now see, again we know that alpha is tan inverse of 2, okay, or tan alpha is equal to 2. Therefore, sine 2 alpha will be 2 tan alpha divided by 1 plus tan square alpha. So that is 2 into 2 divided by 1 plus 2 square. So that's 4 by 5. Okay. So this is this divided by g. So this particular range is this much. Whereas using the same speed of projection, the maximum range would be u square by g. And for that, we should take the angle of projection as 45 degrees. So the ratio of this range to the maximum range is u square, is basically sine 2 alpha is to sine 90. So this one is 4 by 5. So this answer should become 4:5. Is the question clear?
Yes, sir.
So it turns out for these type of questions, this type of identity is quite important. Okay. When you're doing the solving, this is one of the important identities. So actually from this you can also understand that 2 alpha, it's okay. You can check out the value also using a scientific calculator, though we don't require it here. Sine 2 alpha is 4 by 5 means that 2 alpha is 53 degrees. So alpha is about 26.5 degrees. Okay, so these are the doubts I received for the projectile motion worksheet. Okay. Now next I have received some doubts from Kirti for
Sir,
module exercise. Yeah.
from this worksheet, question number 3 also I sent.
Question number 3 also. Okay, we'll discuss that. Okay. So I'm clearing this now. Hope this is clear. This question is done. So let's go back to question number 3, right? Yeah, this one here. Particle leaves the origin with the initial velocity of this much, okay, in meters per second. It experiences a constant acceleration of this much. So what is the velocity when it reaches the maximum x coordinate? Okay. So for this, now this is like a fundamental question. Okay. So we have to rewrite the equation of motion like we have done for projectile motion, like that we have to do. So I'm switching to my whiteboard to explain this. Okay. So the initial velocity is given in question number 3 to be 3 I cap in meters per second, equal to 0, and it has a uniform acceleration given to us as minus, it should be I cap minus j cap. Okay, there's a misprint over there. Both of them are written as j and j, so it doesn't make sense. Okay, we just write it as minus 1.00 I cap instead of j. Okay. So that's an obvious misprint. We'll get that corrected. Meters per second square. So this information is given to you. It has a constant acceleration. This much. Okay. So we have to find the value of velocity when the particle reaches the maximum x coordinate. Find instantaneous velocity at the instant when the x coordinate is maximum. That's one thing, and you have to also find the position of the particle at this instant, same instant. Okay. So basically, we have to find the maximum of the x coordinate first of all. We have to find the x coordinates maximum, okay, and the time at which this is occurring, that x is equal to x maximum. So for that, you have to start with writing the equations of motion. For the equations of motion, it's a 2D motion in the xy plane. So take the x component and take the y component separately. Start with this. So along the x-axis, my initial velocity is +3 and my acceleration is -1 meters per second square. Along the y-axis, my initial velocity is 0 and my y component of acceleration is -5 meters per second square. Okay. So at time t, to find out how much is Vx, how much is x, how much is Vy, how much is y, and then you can answer this question next time. Okay. So I'd like all of you to try this out first. Okay. Just work out these quantities which I have put with question marks over here. Then we'll answer the particular questions that are there in this. So just use the standard equations, okay, for the individual components. Yes, very good. That's correct. Oh, it's -0.5, is it? Okay, my mistake. Just let's make a correction here. This acceleration is given to us as recap. So this should be -0.5. Yes. So Vx as a function of time will become how much? It will become 3 minus t, and the x coordinate as a function of time will become 3t minus t square by 2, and Vy as a function of time will become minus 0.5 t, and y coordinate as a function of time will become minus 0.25 t square. Okay. So now looking at the x coordinate as a function of time, so we can take 0.5 t common, so we will have 6 minus t. So you can see that the x coordinate as a function of time is like this. So at 3 seconds, it's becoming maximum. So x is equal to maximum at t equal to 3 seconds. So at that instant, the x coordinate will become 4.5 meters. And the y coordinate from here will become minus 2.25. And the x component of velocity would obviously have become 0. The y component of velocity would have become
minus 3/2.
yes, minus 3/2. Correct. So these become my answers. Okay, very good, Kirti. Your answers are correct. Okay. And also Anirudh. Okay, so hope this question is clear. Now moving on to some doubts from the module which have been asked. Kirti, you have asked exercise 1, question 15 and 27. So module 1, kinematics, exercise 1. Let's move on to that next. Fifteen, 27 and 37. Okay, let's look at these questions.
Sir,
Yes,
sir, 21 also.
21 also. Okay, we'll discuss.
21 also.
Okay, okay. So let's start with question 15. So I'm just sharing the question first. Note down question 21 also. Okay. So question 15 says that we have a particle which is projected vertically upwards from a point A on the ground. Okay. And it takes time t1 to reach a point B, but it still continues to move up. And it takes a further time t2 to reach the ground from the point B. Okay. So basically then what is the total time of flight? It is t1 plus t2. No? Is this point clear?
Yes.
It's like from the ground level, no, you have projected it at t equal to 0 at some speed u. Okay. Now it's going up to some maximum height like this and then coming back down. But in between, it crosses this point B over here. Let's say at some time t equal to t1. And then from here, it takes another time t2 to reach the ground. So when it's reaching the ground, it's reaching the ground at t1 plus t2. No? So that is your total time of flight. Okay. So then you have your formula that capital T, which is 2u by g, is equal to t1 plus t2. So from this, you can see that your projection speed is becoming how much? Your projection speed is t1 plus t2 into g by 2. So from that, your maximum height will be u square by 2g. So just substitute u in terms of that. So u square by 2g will become how much now? It will become 1 by 8 into this thing. No? So I think this should be the answer.
Yes.
Okay. So just make a quick note of this if you like. Then next we are moving on to question 21.
So can you also do question number 13?
1, 3, 13?
Yes, sir.
Okay. Yeah, we'll discuss. Okay, so let's move to question 13 next then.
Sir, I solved most part of it, but I'm getting stuck at I think the last step. Not getting
Okay, no
into-
problem. We'll discuss. We'll discuss. Okay, so let's have a look at this question. So particles takes t seconds less and acquires a velocity of v more in falling through a certain height on a planet where the acceleration due to gravity is 8g compared to when falling freely falling motion of a particle on another planet where the particle is released from rest at the same height as the previous planet. Let's try to understand this. Yeah, so it's a bit of a tricky question language wise. So what is happening is that it is taking this much less and acquiring this much more speed when falling through a certain height on a planet where the acceleration is 8g. Okay, so I'm switching to my whiteboard. So let's just compare the situation in the two planets. So in planet 1, say, the acceleration due to gravity is 8g. Okay, and in that falling through a height h, starting from rest, let's say this reaches a velocity v1 at a time t1. So our v1 is square root of 2a1 into h. Okay, and our t1 is square root of 2a1 by g. Now compare the same situation to the second planet. You're dropping it from the same height h, but in the second planet your acceleration due to gravity is how much? It's 2g, right?
Yes, sir.
Yeah, acceleration due to gravity is 2g. Okay. So here if it reaches a velocity v2 at a time t2, now it's given to us that t1 is equal to t2 minus t because it takes t seconds less. Okay, and acquires a final velocity v1 which is v meters per second more. So this information we have to use. Okay, so here t2 is square root of 2h by a2. Okay, and v2 is equal to square root of
Sir,
2a2h. Yes,
sir, T1 should be root of 2h by a1, right?
2h by a1. Yes, 2a by g. This is 2h by a1. Okay, so v1. So now let's use this information first. Okay, so v1 which is square root of 2a1h is equal to v2 which is square root of 2a2h plus v. So let's substitute the values. So this is 8g, so 16gh is equal to square root of this is 2, so 4gh plus v. So we have 3 root gh is equal to v. Okay. So 9gh is equal to v square. So this is giving us a value of h in terms of g. This is the height from which it must have been dropped. Okay, and we also have that this equation. So t1 which is square root of 2h by a1 is equal to t2 which is square root of 2h by a2 minus small t. Okay, so square root of 2h by 8g is equal to square root of 2h by 2g minus t. So square root of h by g, if you take common, then you have 1 minus half is equal to t. So we have 1 by 2 root h by g is equal to t. So this is giving us another relation that t is equal to, or from this we can see g can be written as h by 4t square, correct?
Yes, sir.
We can substitute that here and we can get this h in terms of the given quantities, which are v, h, and t. I mean v and t. We can get the answers in terms of v. Independent of g, we'll get the answer. We'll get the value of h independent of g by substituting g in terms of small t. Yes, so it's a manipulation based question, as you can see, but just trying to do it mentally can become a little bit tricky. So it's better that the way I've done it, I've just separated out the two situations, written the equations in terms of A1, A2, then substituted. So I'm not making any mistake while calculating. Okay, so hope this is clear.
Yes,
Anirudh,
sir.
the method is clear. Okay, very
Yes,
good.
sir. I'll just write
Okay,
it down.
okay. Now, yeah, you can just write this down. Then we'll move on to question 21 next. So go through question 21, those who have finished with this. Okay, so I'm switching now to question 21. Yeah, this is a very interesting question. Let's discuss. So you have three particles, A, B, and C, which are thrown like this. Okay. One is a horizontal projection from a height, the other is a vertical projection from the point C. The third is an oblique projection. Okay. And the angle for B is given to us as 30 degrees, this angle. Okay. And simultaneously at H, which is the highest point of the parabolic path. Okay. So this height is equal to H. So that means this is also R by 2. Okay. So now what I'll just do is I'll take a common coordinate frame for all of them. Okay. Where the origin is does not matter. So if they collide here at some time t1, so you can see that at t equal to t1, the x displacement for A should be equal to VA into t1, and that should be equal to R by 2. Okay. The x displacement for B should be VB cos 30 into T1, and that should be R by 2. Okay. And the x coordinate for x displacement for C should be 0 because it's just making a vertical displacement. Okay, so comparing this equation and this equation, we'll get one relation already. So one relation we'll get is that VB cos 30 should be equal to VA. That's the first thing we'll get. Okay. And we'll get that T1 is actually 2 VB sin 30 I mean, half of this. So basically, let's get this equation. Get this. Okay, because it's equal to r by 2. And so these are the first things that we are getting. Okay. So from this, we can see that VA is to VB will become cos 30, that's root 3 is to 2. Okay, that's one thing. Now you can see that C and B should reach the same height simultaneously. Okay. So at this time T1, oh sorry. So at this time T1, the y displacement of B should be equal to the y displacement of C. Okay. So VB sine theta T1 minus half G T1 square should be equal to VC T1 minus square. So this will show you that this term is already equal to this term. So this term must be equal to this term. So it will show you that VB sine theta is equal to VC. So this will show you that VC is to VB is 1 is to 2. Okay. So ultimately this is showing you that VA is root 3 by 2 times VB. Okay. And VC is VB by 2. Okay. So VA is to VB is to VC is root 3 by 2 is to 1 is to half. So that is the same thing as root 3 is to 2 is to 1. Okay, so hope this is clear. Kirti, is the question clear, beta?
Yes, sir.
Okay. So next we are doing 27th, right? So finish writing this up and we'll do question 27 next. So if we finish, then just go through question 27 in the meantime.
Sir,
Yes.
sir, for question 27, first, I derived a relation, and if I substitute that relation, one of the options, I got the answer. So is that method fine?
Yeah, I mean, for objective questions, beta, that method is fine, especially at the exam level. But see, after getting the answer by that kind of elimination method, when you're doing an exercise question, you should also try to solve it by fundamentals and see if you can actually do the question in the straightforward manner. At the exam level, it's okay if you're eliminating and you don't have enough time to verify the whole thing, but you're confident that your elimination is correct. You have not made any mistake in the mathematical steps. Then you can always answer the question that way. Getting my point now?
Yes, actually, I have to get the value, and I got the value right. So I think the elimination should be right only, I think.
Yeah, you should. Okay, so I'm moving on to question 27 next. So let's go through this question. So R is the horizontal range of a projectile fired with a certain speed at a certain angle on the horizontal plane, and H is the maximum height, the maximum horizontal range that can be attained for the same speed. Okay. So this is the idea that for a certain angle of projection, R is the horizontal range and H is the maximum height. So U square sine 2 theta by G is equal to R, and equal to H. Okay. So if you divide these two equations, you can also see that tell you that tan theta divided by 4 tan theta is equal to R by H, or R is equal to so this is one relation that we have between the given R and the given H and theta. This is the relation that we have. Just divide this by this, so you'll get this. Okay. Oh, sorry, this is that's what I thought. This is cot theta. So sine 2 theta divided by sine square theta. Like this, or you can say H is equal to R by 4 tan theta. I've shown you this relation from equation of trajectory also before. Okay, so remember this. Okay, now the maximum horizontal range that can be attained with the same speed as the projection speed before. So what is the maximum possible horizontal range? That is U square by 2G.
Yes.
So how we find this value? So from here you can see that
This is U square by G, right?
sorry, U square by G.
Yes.
Yeah, that's correct.
Equal by G.
U square by G. So now I have to write that value of U square by G in terms of these quantities, no, which are known to me, H, R, and all this. Okay. So for that, from here you can see that U square by G is equal to how much? R by sine 2 theta. Okay. And from here you can see that tan theta. So you can eliminate this way. You understanding my point? So from here you can see that tan theta can be written as H by 4R. Okay. So therefore sine 2 theta can be written as 2 tan theta. So divided by 1 plus tan square theta. Okay. So this will become H by 2R divided by, if you take LCM and all that, 16 R square plus H square divided by 16 R square. Okay. So this will become 8 R square H upon H square plus 16 R square. You just check my calculation works. Sine 2 theta will be like this. Okay. So then your R max, which is U square by G, will from here become how much? It will become R upon sine 2 theta. Take this to the numerator. So just solve this a little further and you will get the answer.
Yes, I will.
ऐसा आ जाएगा divided by 8 RH. So you'll get one of these answers. Okay. So again, it's like manipulation based question.
Sir.
Yes.
So what I did was same thing. I just found R and H in terms of UNG, and I substituted the values of R and H in the different equations.
Correct. You can do it that way also. Yes, that's correct. So the idea is you're using the same set of formulae, na? And
Yes.
just slightly different manipulation, but
So it should be 8 RH, right?
8 RH in the denominator, na? Yeah. Yes, no?
So the R will get cancelled in the like sine 2 theta is 8 RH, not 8 R square.
Achha. In this, it's getting cancelled, is it?
No, sir. In the last step, R will get cancelled. So sine 2 theta is 8 RH, not R square H.
In this, you're saying this step.
Yeah, sir, it's R.
This is R, is it?
Yes.
Yes, yes, it is R. Correct. So let's just make a correction here. So this should be 8 RH, na? And therefore here there won't be any R. Okay, now it's all right now. This will be just 8H, right?
Yes, sir.
Okay. So your answer will become H by 8. Okay, plus 2R square. Doesn't seem to be matching any of the answers now. Just check my calculation. Have I done something wrong?
Sir, I think it's 4 tan theta. It is equal to R by H.
Okay.
No, sir. No.
H is equal to R by 4 tan theta. So tan theta is 4H by R. Oh, yes, yes, yes. This is wrong. No? Tan theta is 4H by R. So this is wrong. Okay, so let's just work out these steps again. That is where the mistake was happening. So this is giving me that tan theta is equal to 4H by R. So sine 2 theta, actually we'll substitute it in another way to be more convenient. So what I'll do is I'll directly substitute in the formula. So my R max, which is U square by G, becoming R upon sine 2 theta. So that R max can be written as R into 1 plus tan square theta upon 2 tan theta this way. And then I can substitute this. So it is R into 1 plus 16H square by R square divided by 2 into 4H by R. Now this should give you the answer. This is the answer.
Yes, sir.
Okay, now we also have question 37 from exercise. Which one is it now? Exercise 2 or 3? Okay, exercise 1 only. Yeah. So next we'll move on to question 37. Just finish noting this down and go through that question. I'll explain. Okay, so I'm moving to question 37 now. So it's launched from the ground level with a speed u at an angle theta. What is the average velocity between the two instants that it crosses half of the maximum height? Okay, so this is a very interesting question, and actually it can be solved by using a very simple concept, that is solving the concept that average velocity is displacement upon time. So if we just use that idea, it becomes very simple actually. So let's say this is the horizontal ground from which we have projected. The speed u at an angle theta. So the particle is following this kind of a trajectory. It's reaching a maximum height in between of h. Now let's say at some time t1, it's reached here, and then again at a time t2, it's reached here. We want to find the average velocity from t1 to t2. Okay. So that is the displacement from t1 to t2 divided by the time interval. Now the displacement, whatever it is, you can see it is just a x displacement. If this coordinate is x1 and this coordinate is x2, it is x2 minus x1 I cap upon t2 minus t1. So you know that it is u cos theta
Sir, I got this answer.
u cos theta I cap. This should be the average velocity. So don't really need to solve for t1, t2 and all that and do it that way. You can just understand it from the definition of average velocity, that it is displacement upon time.
Sir,
This question would, yeah.
sir, I got the same answer, but I can use a different method. Like if it reaches maximum height at u sine theta by g, so it will reach h by 2 at u sine theta by 2g, and it will reach at
No. Wait. It will not reach at that because see, it's not a linear function of time, the height, no? It's a quadratic function of time. So to find this time t1 and t2, now you have to actually solve this question. H is equal to u square sine square theta by 2g. Okay. So h by 2 is u square sine square theta by 4g. Okay. So what is happening at t equal to t1 or t2? Your y coordinate is equal to h by 2. Okay. So y in general is u sine theta t minus half gt square. You're following it? So here you have to substitute h by 2. And the roots of this equation will give you t1 and t2.
No, sir. I use the t is equal to 2u sine theta by g formula.
What?
T is equal to 2u sine theta by g. I use that
That is
formula.
total time. That's okay, beta. That is total time of flight. Okay. So total time of flight is 2u sine theta by g.
Yes,
And
sir.
therefore the time here is
It's
t
u
by
sine theta
2.
by g.
But the time t1 is not t by 4, beta. This is not going to divide in half. You understanding? Because
Okay.
your y coordinate as a function of time, na? It's like this, na? So it's a curvature, na?
No, sir. I
You can see
consider for
this
the
is,
x-axis.
huh?
I consider for the x-axis. It's a linear function too.
For x-axis it is a linear function, but this is not r by 4, no? You're understanding x1 is not r by 4.
No, sir. I
Yeah, x1 is
calculated
actually
x1 separately.
using equation of trajectory.
No, the normal equations only.
So in the normal equation, what is the value of t1 you have used? That's what I'm trying to explain. To find t1, na, you have to solve this equation t1 and t2. You're understanding my point?
Okay.
This quadratic equation, the roots of this equation, this is an equation of this type now, that half g into t square, okay, minus u sine theta into t plus u square sine square theta by 4g is equal to 0. So the roots of this equation are b plus minus root of b square minus 4as so it will become this, okay, divided by 2a. So you will get t as u sine theta by g. If you take common, you will see you will get 1 plus minus 1 by root 2 like this. So your t1 is actually u sine theta by g into 1 minus 1 by root 2, or it is capital T by 2 into 1 minus 1 by root 2, and your t2 is u sine theta by g into 1 plus 1 by root 2. So that is t by 2 into 1 plus 1 by root 2. So from this now you can find x1 as u cos theta t1, x2 as u cos theta t2. Okay, but what I'm saying is all that is unnecessary, no? Because already directly from the displacement upon time formula. Okay. Hope the point is clear, better.
Yes, sir.
Because here we are taking that special case, na, that we are taking such times at which the vertical displacement is 0. In our time interval, the vertical displacement is 0 because both of them are at h by 2. So we don't have to do all this calculation. The average velocity is just the horizontal displacement divided by time. So horizontal displacement happens at a uniform rate. So the average velocity is u cos theta I cap. But suppose we were calculating, let's say between the average velocity between this time t1 and the total time of flight t, then we could not have relied on this method alone. We'd have to calculate. Okay. Understood?
Yes, sir. Yes, sir. I got it.
Okay. Okay, so people, with that we'll conclude today's session. Okay, next session we will start with relative motion, which is the last part of kinematics. Okay. Also, any pending doubts in projectile motion, we will complete that up in due course. Don't worry. Okay. So wish you all the best, and also have a good Ganpati vacation of 1 day or 2 days, whatever you're getting. Okay. We'll pick it up from here in the next lecture. Thanks for attending. Wish you all the best, people.
Sir,
Thank you, sir.
Yes.
so what is the NLM portion for major test 4?
NLM portion, I think it will be up to constraint relations, like system of pulleys and constraint relation.
So pseudo force and non-inertial frame is not there.
Yeah, I think that will not be there. Just clarify with Hemant sir once, but I think pseudo force will not be there.
Okay, so pseudo force will not be there for major test 4, right?
Yeah, but clarify once with Hemant sir. No? Just drop him a message or ask him on the group. He'll confirm.
So he's saying that he's not sure about it. I asked him in the last class.
Okay, okay. So anyway, there is some time to go for major test 4, no? So we will confirm it before that. Okay? In 2-3 days time, we'll confirm it when we make the paper. Okay.
Okay, sir. Sir, and I've also sent you a doubt. That question is from NLM, but it involves some kinematics in that. The question is like two masks are hung from two sides of a pulley, and when will each mask cross each
Okay,
other?
I'll take a look at that question and send you some hint. Okay. I have another class coming up right now, so I'll pick up that question maybe later in the evening today and send you a hint. Okay.
Yes, sir. No issues.
Okay. Okay. All the best.
Thank you, sir.
Okay.
So that's a relative velocity problem, right?
Which one?
The one he just told now.
I have to see the question, but I haven't seen the question yet. Okay. I'll pick it up in the next lecture or in the next doubt session. Okay.
Okay, sir.
Thank you, sir.
Okay. Okay.